Kids. Hope you had a good snow day yesterday, and I am sorry to be out as well today. And hopefully you watched the Mr. Chase's lesson for the first day of related rates, and Mrs. Hammond should have a couple of handouts for you, a warm-up with these questions on it, the avalanche packet with the odd problems that you were to do last night, and then tonight notice that you have the even problems in the avalanche packet that aren't due until Monday. I've also created some Khan Academy assignments that aren't due until midnight. There's some videos and some exercises. I need everybody to join the class code before the assignments can go in, so I'll wait until tonight. I'm sorry, yeah, tonight for you. This is Thursday night for me, but for you, Friday night, I'll wait to see if everybody's joined. So if you could all join today, and then by this evening, I will make the assignments visible, and those are due on Sunday night. Tuesday, we will have a quiz that you're allowed to use your calculator on. There will be optimization problems, related rates problems, and linearization problems. Then on Wednesday, we will have our AP6, and that will have optimization and related rates. You'll also be allowed to use your calculator on that. So that way, though, you'll have two things with optimization and related rates on it that you'll have feedback on before you take the test. All right, so hopefully you've had a chance to look at this warm-up. And I'll start going over it with you, and then I will go over a couple of a problem from an odd problem and an even problem from the packet. So remember, for related rates problems, you're looking for how fast, as opposed to, remember, optimization problems needed, you were asked, what am I maximizing or minimizing? So when I'm doing it, when you're looking at a test and you're not sure, is this optimization or related rates, you see the words how fast. You see the words how fast. There's time into the situation. So how fast is the radius of a spherical bubble changing when you blow air into it? At a rate of, and its radius is. So how fast is what I'm trying to find. But I'm given a rate of what? Cubic centimeters. What is that? I'm given the rate of change of the volume with respect to time, and that is 10 cubic centimeters per second. I'm trying to find what? How fast is the radius? So how fast is the radius changing with respect to time? The rate of change with respect to time of the radius. That's what I'm trying to find. Now relate the rates. Now remember, when in my relate step, I want to get an equation with volume and rate into it. I don't need derivatives yet. So what equation can you write to relate the volume and radius of a sphere? The volume of a sphere, no calculus, is 4/3 pi r cubed. There's my relate step. Now, I check at the relate step. Is there any variable here that is constant even when time passes? So I've got the radius in my sphere, but when is time? When I see the when word, so I have a volume that is changing as I blow bubble, and as I blow air into the bubble, the radius is changing too. So I cannot put a number in for volume or for radius before calculus. If your value is changing with respect to time, you cannot put any values in until after you differentiate. Remember also that in between here, I should also mention that in here, I should be asking, are there any variables I need to replace? In other words, are there too many variables to display? But I only have one independent variable, so I do not need to replace anything, and I can go right to differentiating. So differentiate the rate of change with respect to time of volume is, bring the 3 down, and I just have 4 pi r squared, spit out, this is an r, remember when you have the variable of differentiation is not the same as the variable in the equation, we have implicit differentiation, so you need to spit out the derivative of the radius. Take a check. I have dv dt after differentiation, and I have dr dt after differentiation. Now I can plug in values that change with time. What do I plug in for? Am I plugging in for volume, or am I plugging in for radius? Or am I plugging in for dr dt? What am I trying to find? Right, you're trying to find dr dt. So I'm going to plug in 10 for the rate of change of volume with respect to time. When the radius is 2, and I'm solving for dr dt. So what is that? 10 divided by 16 pi, which is approximately 0.198 centimeters. A radius is not cubed or squared, right? A radius is only linear. 0.198 centimeters per second. Now B, how fast, related rates, is the water level dropping when a cylinder with a 50 centimeter diameter is drained at a rate of volume. 3,000 cubic centimeters per second is the same as 3 liters per second. So what am I given? I'm given a rate, right? What rate am I given? I'm given, again, the rate of change of volume with respect to time is draining and I'm going to go ahead and keep the 3,000 cubic centimeters per second since my radius, or I'm sorry, my diameter is in 50. is 50. Now, what does a cylinder look like? This diameter is 50, right? 50 centimeters. And what am I asking? There's a water level in here. That's the water level, and they want to know how fast is the water level dropping. So what is that relative to? If I have a cylinder and I'm talking about the volume of a cylinder, right? I'm talking about the area of the base times the height. So this is when is the height dropping, right? So I want to find dH dt. Relate the variables we want to relate volume and height of a cylinder. So we want an equation with volume, area of the base that has the R. That's too many variables to display. So do I need to replace? I don't want to replace H, right? I don't want to replace H because H is, right? I want to find a rate involving H. So it's this R I want to get rid of. How annoying, because R is also being squared. Wait just a minute. Wait. I do not need to replace, because what's true about the radius of a cylinder? No matter how that water goes up and down, what's true about the radius of a cylinder? Radius is constant in a cylinder. It will not change with time. So I actually don't need, I was worried for a minute, I don't need to replace R in terms of H. I can replace before calculus because the radius is constant. You best not put 50 in there, right? Radius is 25. So the equation that I need to differentiate, I need to differentiate volume with respect to time. Right? This is 625 pi h. So when I differentiate a constant, 625 pi is just a constant, right? What is the derivative of a constant times a function? It's the constant times the derivative of the constant. Now what do I have my given? And I have what I'm trying to find. I'm trying to find dH dt, and I'm given dV dt. I'll go over here. Negative 3,000 is over 625 pi. Ooh, I forgot my pi over here. Is the rate of change of the height with respect to time. And that's approximately negative 1.528 centimeters per second. Now you could drop the negative as long as you could also say in words the water level or the height is decreasing at a rate of 1.528 centimeters per second. Okay, don't forget to join Khan Academy, either second period or fifth period. All right, so let's go and let's do some more problems. So look at number 17. This was from your avalanche packet. This is a very traditional related rates problem because it involves both a cylinder and a cone. Coffee pot problem. I'm pretty sure one of the videos I assigned your practice problems for Khan is also, hey John,
yeah,
a coffee cylinder pot problem. So coffee is draining, think negative, from a cone into a cylinder at a rate, oops, that's mistyped, of 10 cubic inches per minute. So the first problem, how fast? So I'm doing related rates. How fast is the level in the pot? Now wait a second, I have two shapes. So is the pot the cylinder or the cone? Methinks it's the cone. So this one, merci beaucoup. So this is, oh, what a poor looking cylinder. So how fast is the level of the coffee? So that's height, right? How fast is this level rising? When, there's my time, the coffee and the, oh, there's the cone, 5 inches deep. All right, so let's try to break this down. What do I want to find? I want to find oops, sorry. What am I given, silly? What am I given? The rate I'm given, 10 inches cubed. What is that? The rate of change with volume. Now coffee is draining, but they want to know that it's draining from the cone, but it is rising. In the pot, right? So when it's draining, it's negative, but when it's rising, and if it's falling out here at, the rate it's falling out of the cone is the same rate it's going to be rising in the pot. So what do I want to find? I want to find the rate of change of the height. Relate. Now where is this height? Is that height in the cone or the coffee pot? Right? This height relative to this volume is in the coffee pot. So I want to relate the volume of a cylinder. That's the area of the base times the height, which again started to worry me about too many variables. Do I have to replace? And how I figure out I have to replace, if I have to replace or not. Remember, I don't want to replace h because that is, I want to find dh dt, so I don't want to replace that. So do I have to replace r? and the r is being squared, I have to either replace that in terms of h, or is r a constant in a cylinder? Since r is constant, I do replace, but I replace r as a constant so I can replace with a number. So I'm going to go up here and say volume is equal to pi. What is the radius? Oh, that's right. It wasn't in the words. I started to panic for a minute, but they gave me the radius here. Well, they gave me the diameter, right? Right, 9 pi h. Now I'm going to differentiate. So the rate of change of the volume with respect to time, 9 pi is just a constant. So the derivative of a constant is the constant times the derivative of the function. Use your given. And there's your answer. 10 divided by 9 pi. Oops, what's my units on this? Inches, right? Inches per minute. Get a decimal if you like. Next it asks me, how fast is the level in the cone falling at that moment? So the level in the cone, right? Here's the level, right? When they talk about level, what are they talking about again? Right? So I'm still given, what am I given? Same thing I was given before. I was given the rate of the volume, right? This time it's draining out of the cone. So it's draining this, and then they want me to find, they still want me to find the rate of change of height, the level, right? But this time the height that they're talking about is in a cone. So when I do my relate step, I have to do the volume of a cone. So the volume is pi r squared h. The volume of a cylinder multiplied by a factor of a third. So the problem here, though, is that when I think I need to replace, this time I don't want to replace the h because I want to leave the h again, because what I'm trying to find is dh dt. So I have to go after the radius, and this time the radius is not constant, right? Here's the radius when the level of the coffee is here, but what happens when the level of the coffee is here? Isn't the rate smaller? So this is where we have to use geometry and similar triangles, just like I showed you yesterday, or Mr. Chase's video showed you yesterday. There are two triangles here, and they're similar. There are actually lots of triangles, right? And each one has a different radius, but they all share a right angle and they all share the vertex angle. So take the best case scenario. If the cone was full, what would the radius of that large triangle be? Right? Because this radius is smaller. This radius is even smaller. But what is the radius when it's full? And what's the height? What is the height of this triangle when the cone is full? Right? The height is 6, right? So in my replace stage, I've got a triangle. Let me draw it over here. I have a right triangle with this side 3 and this side 6, and then I have a similar triangle where I don't know this small radius and I don't know this smaller height. But since they are similar triangles have proportional sides, so 3 must be to 6 as little radius is to little height. Who do I want to replace? I want to replace R. So can you solve this proportion, this equation for R in terms of H? R is 1/2 H. So go to your volume equation and replace R with H. So I get 1/3 pi 1/2 H squared times H, which means I really have pi over 12 H cubed. Finally, I'm ready for calculus. Differentiate, bring down the 3. You bring down the 3 in front, cancel out, you get pi over 4. Copy over the H, subtract 1 from the exponent, and spit out the derivative of H with respect to time. Put in your given, isolate your find. Whoops, forgot to put dv dt over here, sorry about that. So -10 oh, sorry, what is now I can replace H with that moment. What is that moment? Right, that moment goes all the way back up here when the cone is 5 inches deep. I think it was a little annoying that they put the 5 inches up there in part A when I didn't actually need it until part B. So I replaced this H with 5, and that's where I got 25 pi. On that side. So I have that 4. Maybe I should just show this more, huh? I think I confused you, I'm sorry. So I have -10 is equal to pi over 4, 5 squared dH dt. So dH dt, when I try to get dH dt by itself, this 4 I'm going to multiply times negative 10 and get negative 40. And then I'm going to divide by this 25 pi. And that's in inches per minute. Woohoo! So that was number 17. That was one of the odd problems from last night's assignment. Tonight you're supposed to do the even problems, so I thought I'd do one of the nastier even problems, I think. I think this is a little overcomplicated, but I liked it for the first part of the problem. I think is more reasonable. And I like the problem because it does remind you about things, thinking about any pieces of the puzzle, if you were, that are constant before calculus. So they give me this picture here. Water is flowing at a rate of 6 cubic minutes from a reservoir shaped like a hemisphere with a bowl of radius 13. So the bowl, right, when I think about this, the bowl has a radius that doesn't change. But the water level, if you're talking about the water level is going to change, right? The radius of the water level. So given that the volume of the water of radius capital L, capital R, is this thing, right? Blah, 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 blah. They're using y for height. Right, there's your y, and y is also over here. So notice this is volume, and I do have y cubed, yes? So it's this thing that's annoying, except, I think again, they're trying to be a little cute here. If the bowl is of radius r, but what did they tell me my bowl has a radius of? Right, so I'm just going to replace that r right away with the 13, because the bowl's radius isn't going to change. And then I just did some algebra on that. Right? Got rid of the parentheses because I'm going to be taking a derivative, and the derivative of a difference is just the difference of the derivatives. So next I read, at what rate is the water level, what's my water level? Right, isn't that my y? Changing when, there's my time, the water is 8 meters deep. So I've already related, right? They want the rate of change of volume with respect to time. I'm sorry, here's my volume and here's my y's. I only have one independent variable, and that variable represents the height, and that's what the height of the water, or the water level, and that's what they're asking for. So they're asking for dy dt, right? This was my given rate, right? Flowing at a rate of 6 cubic meters, right? This was my given, dv dt. So I factored out dy dt because that's what I was trying to find, and simplified. So I don't think that was your pretty standard. What's my given rate? What do I want to find? And then I already had the relate. No replacing necessary. Really, the replacing was done very early on with that capital R. Next, notice this. So this question here is them trying to help you answer this question here. So they're now asking about the little radius of the water surface. That's the one that is changing. So my question is, what I need is an equation. I know what I'm given, right? They're asking what's the rate of the radius changing. So I know I'm trying to find the rate of change of the radius of the water changing. The problem is I need an equation with little r. That's what this is asking for. This is asking you to create an equation for little r. So I need to go up here and say, when I go up to the equation, to the picture, I notice that little r here, they've given me a hint and drawn, because a radius from the center of the sphere out to the bowl at any place has got to be 13, right? That's what it's a hemisphere. And then this, of course, is the rate of the height of the water. But with the water level, it makes a right triangle. So since that's the little r I want, this is a height I don't really care about, but it's in a triangle that will get me little r. What do you know about this height? Isn't that height? This whole height is 13, isn't it? And this y is the height of the water level. So what is this little piece here? Isn't this little piece 13 minus y? And now can't I just Pythagoras? Whoops, I'm sorry. Can't I just say that 13 squared is equal to little r squared plus what? 13 minus y squared. But doesn't that mean that r is equal to the square root of, right, if I expand all that out, (169) minus 13 minus y squared, which is 169 minus 26y plus y squared. Gee, what happens to the 169s? Now remember down here, at what rate is the radius changing? So I want to find dr dt. And I'm talking about when I'm going to be given a y, right? This is a water level height. And I have an equation that relates r and y. So differentiating this, think about this equation to the 1/2 instead of the square root. So wouldn't that be 1/2, copy over the middle, to the negative 1/2 times the derivative of the inside, which is 26 times the derivative of y, minus 2y to the first times the derivative of y. right? So now I have an equation where I am asked for the rate of change of r with respect to time, and I can plug in 8 for y, so I'm going to be plugging in 8 here, 8 here, 8 here. Oh no, that leaves me though with dy dt here and dy dt here. That's another unknown. Or is it? Wait a second. We found dy dt. So dr dt is equal to 1/2 26 times negative 1 over 24 pi minus 2 times 8 times negative 1 over 24 pi all over 2 is also underneath here, right? I'm just going to take this all to the bottom, all over the square root of 26 times 8 minus 8 squared. So this 2 will cancel out with that, make that a 13, and cancel out that 2. And then I do a bunch of math, and I end up with negative, bunch of fraction work, negative 5 over 288 pi. And what are my units? My units are meters per minute. Phew, my Lanta. All right. So I think I've taken care. I think the one of the other problems that is a little hard is that trough problem. My hint for that is to think about that trough as standing the triangle edges, like stand it straight up, right? So it's laying on the triangle side, so the triangle is the base and then the water is the height. Think about that. I think the other ones are fairly routine for related rates problems, but related rate problems are not easy. They take time. I will post the solutions to this packet on Sunday evening, like when you're finishing the Khan Academy, so that you can look at them before Monday, before you come in on Monday. All right. Have a good rest of your day and evening, and I will see you on Monday.